A ladder rests against a wall, a smooth wall and a rough floor, making an angle theta with the vertical. Right, well, let's start off with looking at this reaction force that's drawn in red here. The reason that it points up at an angle is because the reaction force from the wall is perpendicular to the wall because it's a smooth wall. And we've got the weight of the ladder, which comes from the center of the ladder. And those three forces are concurrent. They act through a single point. And that point is halfway horizontally between the edge of the ladder and the wall. So the geometry will help us to get the angle. We're not told the length of the ladder, so we can just make a guess. Let's say 1 meter here. I could have called it L, I suppose, but I'm going to say that the ladder is 1 meter long. Then I can use a bit of trigonometry, and I've got cos 40 and sine 40 here and here. Now, this length here and this length here, because the intersection point is halfway, this is a half sine 40. So I've got a little triangle with my angle phi, and that's cos 40 as well. So I can say that tan of phi is the opposite, a half sine 40 over cos 40, which is basically just a half tan 40. Right, so tan of 40 divided by 2, and then the inverse tan of that gives me 22.76. Right, make a bit of space here. And I probably need to look a bit at these forces, so I'll make a bit of space. The ladder weighs 88 newtons, so I've got 88 newtons acting down. What is the magnitude of the force from the ground, the red force? Well, it will be the vertical component of that force, which cancels the weight. Remember that the reaction from the wall is purely horizontal. So calling it F, I suppose. Then F cos phi equals 88. So I need to do 88 divided by cos of the previous answer, and that gives me 95.43 newtons. And what's the magnitude of the reaction force? Well, this is a horizontal balance of forces. This is F sine of phi, and that's going to equal my reaction force. So that's 95.43 times the sine of 22.76. So the reaction force is 36.92. There we go.